Problem 5, we're going to divide a binomial by a monomial. So this is kind of an equivalent of dividing a 2-digit number by a 1-digit number, okay? So we're going to divide 2 terms by 1 term. So you're dividing a binomial by a monomial, 2 terms by 1 term. By the way, everything we do is going to be division by 1 term, by monomial, because dividing by 2 terms is actually like a whole unit in Algebra 2. So, all right, so let's write out the problem first. 5x squared minus x divided by x. I'm keeping this in parentheses. So as a general rule, if you have something and you know you're going to multiply it or divide it by something else, you got to keep it in parentheses. So I'm going to rewrite the division problem as a fraction. So I'm going to write 5x squared minus x divided by x. And then you might remember this from class. The distributive property exists for division as well. So a plus b divided by c, you can kind of distribute in quotes this division by c to a and to b. So you can write a divided by c plus b divided by c. Both get the c. So what I'm going to do is I'm going to write that as 5x squared divided by x minus x divided by x. From there, you can see that it basically turns into a similar problem to the ones we've been solving. So I'm going to write out x squared as repeated multiplication. So 5x squared becomes 5 times x, and everything else stays the same. Then I'm going to divide out common factors. X divided by x is 1. X divided by x is 1 as well in here. So simplify, I have 5 times 1 times x divided by 1 minus 1 divided by 1. So I have 5x minus 1. X divided by x is 1, not 0. That's a common mistake. And again, not just high school. We're kind of entering more complicated algebra. So it's a common mistake with college students too. X divided by x is not 0, it's 1. Okay, right? Because you're dividing a number by itself. You're not subtracting a number from itself. So 5x minus 1 must resist temptation to keep on simplifying this. This is it. 5x minus 1. You divided a binomial by a monomial, and the result is a binomial. So 5x squared minus x divided by x equals 5x minus 1. That's it. You divided a binomial by a monomial, and the result is a binomial. So it's kind of like you divide a 2-digit number by a 1-digit number, and the result is a 2-digit number. 42 divided by 2 is 21, right? So it's very similar. Numbers are a special case of polynomials. So it's not a coincidence that these things kind of behave in a similar way. Okay. All right, problem 5. So we're going to try something similar, but maybe... Oh, okay, so this is what I just stated. You divided a binomial by a monomial, and the result was a binomial. Okay. All right, problem 6. So now... you're dividing a trinomial by a monomial, so three terms by 1 term. So it's kind of an equivalent of dividing a 3-digit number by a 1-digit number. Okay, so you're dividing 12y to the 4th minus 3y cubed plus 6y squared by 3y. All right, so dividing a trinomial by a monomial. The first thing I'm going to do is write the original problem. Here it is, keeping the parentheses that I was given initially. Then I'm going to rewrite division problem as a fraction. So 12y to the 4th minus 3y cubed plus 6y squared. This is the dividend. I don't know if you remember those terms from elementary school, but the number that comes first in the division is called a dividend, and this is the divisor, right? 3y is the divisor. So the divisor goes in the denominator. All right, then I'm going to apply the distributive property for division. I've extended it for a sum of 3 terms. So a plus b plus d divided by c is equivalent to a divided by c plus b divided by c plus d divided by c. And you don't, I mean, this is just a property of adding fractions. Like if you add these 3 fractions, that's what you're going to get. So I have 12y to the 4th divided by 3y minus 3y cubed divided by 3y plus 6y squared divided by 3y. Write power expressions as repeated multiplications. So y to the 4th, y cubed, y squared. Okay. Let's divide out common factors. 12 and 3. have a common factor of 3. Divide out the 3, you get 4 and a 1. Y and y have a common factor of y. Divide out the y, you get 1. 3 and 3 have a common factor of 3. Divide out the 3, you get 1. Y and y, you get a common factor of y. Divide out, you get a 1. 6 and 3, you get a 2 and a 1. And a y, you get a 1. All right, so simplify. You get 4 times 1 times y times y times y divided by 1 times 1. 1 times 1, blah, blah, and so on. Okay, so you get 4y cubed minus y squared plus 2y. Resist the temptation to keep on simplifying this. This is it. You divided 3 terms by 1 term, and the result is 3 terms. Kind of like if you divide a 3-digit number by 1-digit number, sometimes the result is a 3-digit number, right? Not always, but that's expected. All right, so... Oops, sorry. So 12y, let's state our result. 12y to the 4th minus 3y cubed plus 6y squared divided by 3y equals 4y cubed minus y squared plus 2y. That's it. Just dividing these things, all right? Dividing these things. Problem 7. Okay, problem 7. Divide a binomial by a monomial, 4x cubed plus 8x squared. That's my dividend, what I'm dividing, and what I'm dividing by is 1/2 x squared. All right. All right, let's try this. So I'm going to, you're dividing a binomial by a monomial. So I'm going to first write out the problem, and then rewrite division problem as a fraction. So, of course, I run into a problem of there being a fraction in the denominator. We're going to deal with this when we need to. That's a... Right? That's the most useful advice I've ever gotten in math classes. Just keep on doing things until you run into a wall. So don't, what I mean is don't freeze because you anticipate in like 3 steps that you will have difficulty. Just think about the next step. That's basically what that means. And that, because by the time you get to that 3 steps ahead, you will already have resolved things, okay? So, I mean, this looks so different from the other ones, but let's not panic just yet. Okay, so I'm going to rewrite division problem as a fraction. Here it is. All right, so, and then I'm going to apply the distributive property for division. So I brought it back to a sum of 2 things divided by 1 term. It can be split in the following way. So I get 4x cubed divided by 1/2 x squared, 8x squared divided by 1/2 x squared. All right. I'm going to write things out as repeated multiplication. X cubed is 3x's, x squared is a product of 2x's, x squared is a product of 2x's, and x squared is a product of 2x's. And then I'm going to divide out common factors. So x and x becomes 1, x and x becomes 1. I'm going through this just a little bit faster because we've done this 4 times. X and x become 1, x and x become 1. I'm not sure if 4 and 1/2 have common factors. They actually do, but I'm not sure yet. Okay, so I'll just leave things as they are. We know they do, right? Because you can fit, how many 1/2s can you fit into 4? 8, right? So, but let's say, okay, this is weird. So I'm just going to leave it the way this is. All right, so I'm going to simplify. I got 4 times x divided by 1/2 plus 8 divided by 1/2. Well, now this looks much simpler. If I would have panicked here, I would have never gotten to this step. But I just kept on going. Now this is... I know what 8 divided by 1/2 is because we've done those drills, we've done the worksheets. I know when you divide by a fraction, it's the same as multiplying by a reciprocal. So simplify, and I'm going to recall that like 4 divided by 1/2 is this. When you divide by a fraction, it's the same as multiplying by the reciprocal. That's the definition of division, by the way. Dividing by a number is defined as multiplying by its reciprocal. So 4 times 2 over 1, which equals to 8. So I have 4 times x divided by 1/2. I got 8x. 8 divided by 1/2 is 8 times 2 over 1, or 16. So I got 8x plus 16. So 4x cubed plus 8x squared divided by 1/2 x squared equals 8x plus 16. All right. Okay. Yeah. So I've included terminology here, okay? If you want to go on like find other problems online somewhere or something, just this is what we're doing. We're dividing binomials and trinomials by monomials. So that the topic you would search is right here. Okay, that's a general rule for all math and science classes. All right. Okay. All right. So that's it. I'm going to stop here. There's more, but dividing is so important because in order to know how to factor, you have to be able to divide. So I don't want to create a problem here. So I'm going to stop here. If this feels like it's a little bit easier than our previous classes, I'm intentionally making it a little bit easier. So for this one, you divided a binomial by a monomial, and the result was a binomial. All right, so